Our guest today is Eric Siegel. Eric is a leading consultant and former Columbia University professor who helps companies deploy machine learning. He is the founder of the long-running Machine Learning Week conference series and executive editor of the Machine Learning Times. Now, Eric was back with us back in May of 2019, when we talked about his best-selling book, Predictive Analytics, which indeed has gone on to be used in courses at hundreds of universities. But now he's back to talk about his new book, The AI Playbook, Mastering the Rare Art of Machine Learning Deployment. So, Eric, welcome back to the program. Now, machine learning has been called one of the world's most powerful general purpose technologies, and it can do things like boost sales, prevent fraud, streamline processes, even help fight climate change. But yet, with this unlimited potential, most new machine learning projects fail to deploy and often capture zero return on investment. Why is that? If the technology is so powerful, why does it so routinely fail?
Yeah, that's the big irony. That's the question. And Kevin, thanks so much for having me back on your podcast. Um, that sort of the common misconception is that because it's so technically powerful, that necessarily means it's organizationally valuable. And in the book, I actually call that the ML fallacy. And the fallacy goes like this: since machine learning algorithms actually work, which means to say that they succeed in generating a predictive model that holds up for new unseen situations, which is amazing. That you ascertain from that that the model itself is intrinsically valuable. And that's not true. It's
Hmm.
only valuable if you act on it, if you integrate it, implement it, deploy it, if you change existing operations. The only way you capture value with the model that was generated from data is by actually it's useless, literally useless, unless you use it, unless you actually improve, and that means change existing operations.
It's really all about the application of the technology in ways that really matter, that
Yeah,
move the needle in terms of process innovation and transformation. And you
yeah.
say in the book that people often focus too much on the technology itself and not on its deployment. So what should we be doing differently?
Yeah, we're so enamored with this core technology, as am I. I've been in the field of machine learning for more than 30 years, and much the same as I think most data scientists and a lot of the world in general, is just that machine learning is such a cool technology, such amazing science, learning from data to find patterns that hold true in general over new unseen situations. What could be better than that? But hold on a second. The value is only if you're somehow putting the discoveries, the results of the number crunching into play, right? So it's kind of like today we're fetishizing the core technology rather than its value and its use. It's kind of like being more excited about the rocket science than the launch of the rocket, right? So that's sort of a natural inclination. It's like, this is the best technology. Let's go do it. Let's use it. And the data scientists do their number crunching. But no, we need to reframe machine learning projects that can better target marketing, fraud detection, and better manage financial credit risk, target ads, filter spam, decide where to drill for oil, decide which satellite to change the battery, a million operational decisions. We need to plan on how that's going to be used from the get-go, reframe those projects as operations improvement projects that use machine learning rather than simply being technical or machine learning projects. It's not just the number crunching. It's an
Mm.
organizational process. And that's what my book offers, the AI Playbook, is because until now, there's been no established, standardized practice, framework, playbook, paradigm that's well known to business professionals outside of data science that's necessary to run machine learning projects successfully through to that deployment, to the actual change of operations that act on predictions. I mean, prediction is the holy grail for improving these large scale operations that consist of decisions. And if you can predict who's going to click, buy, lie, or die, commit an act of fraud, or turn out to be a bad credit risk, you can do a heck of a lot better job playing the numbers games that define business and tip the odds in your numbers. So that's the get-go. That's from the get-go of the project. You need to plan that ultimate deployment, and and that sort of reverse planning, business focus, business operation, change management process, that's what's got to be the bigger scope umbrella that surrounds the use of this technology so that we get it deployed successfully.
Now, analysts like McKinsey, Bain, KPMG, and others all point to a rather high failure rate for digital transformation initiatives, upwards of 70, even 80%. The reason for this failure rate often is a lack of connective tissue between tech goals and business goals, and that's kind of what you're talking about, the awareness and marriage of what the real business goals are for improvement. As you mentioned, we could get enamored about flying to Mars, for example. We could get enamored about all the great technology and forget that we're actually flying to Mars is what we're trying to do.
Mhm.
What should technologists be doing differently to put to put this connective tissue into place and align tech goals and business goals in ways that really make a difference?
Yeah, I mean, that's a great question. I mean, the general high failure rate of digital transformation, and yeah, this is yet another example of that, and it's a similar type of failure rate that we're seeing across industry research results, including surveys that I've been involved in, where we surveyed data scientists and how many of their models get deployed.
Mhm.
Um, but it's a little different with machine learning. So, the thesis of my book is that you do require a very particular specialized practice for machine learning in particular that brings in business side stakeholders, and they must ramp up on some of the nitty-gritty detail. But it's not arcane or boring or intimidating. It's not the rocket science. It's how to use and capitalize on the rocket science, and what you have to get your head around when you're involved with one of these projects, get your hands dirty a bit on what's predicted, how well, and what's done about it. So the what's predicted and what's done about it, that defines the use case. So is this transaction likely fraud? Maybe block or audit that transaction. Is this customer likely to cancel? Expend the cost of a discount for retaining that customer if they're at high risk of defection. That pair of what's predicted and what's done about it, that defines the use case. The second of the three, how good is it? How well does it predict? How much value could it generate if we acted on those predictions? Um, you need to get involved as a stakeholder on a certain good level of detail around those three facets that define and plan and drive the direction and use of a machine learning project and its deployment and assessment thereafter. And in that sense, basically, if you don't get your hands dirty, then your feet are going to get cold, because the cold feet thing is what keeps happening. That's the sort of endemic syndrome where
Mm.
we have the number crunching is sound, but the model doesn't get deployed. Stakeholders don't quite get it. They weren't prepared for a sort of fundamental change to an existing large scale operation. They don't understand how good the model is. They understand it's imperfect and it's not a magic crystal ball, but that predicting better than guessing is often very valuable, but they don't know how valuable. They don't know how to turn that concept of imperfect prediction into a concrete metric. So that's where we need to bridge the gap. We need to work a lot harder, bringing together and getting on the same page the data scientists and the business stakeholders around this level of detail.
Well, I want to ask about that, the data scientist part of it. And tell me if I'm wrong, but at least until now, machine learning deployment really required a great deal of technical skill, often leaving machine learning in the hands of programmers and data scientists.
Yeah.
So, how can non-technical professionals begin to better leverage machine learning and indeed collaborate better and more effectively with data scientists?
We still need the data scientists, and I say that in part as a data scientist. But the point is that more than anything, these machine learning projects don't need better technical experts and don't need improvements to technology. They need you. They need a stakeholder who has ramped up on semi-technical, which is not just an hour. It's a book. It's a book's worth. And in fact, that's what I'm hoping to contribute with this book, is that along the way, while it covers 6 steps of a practice that I call BizML across 6 main chapters of the book, actually the main thing the book's really doing is along the way, it's ramping you up on that semi-technical knowledge of understanding that level of detail concretely about what it means to predict from data, what exactly you're predicting, and you need to be involved in defining that, and then how those predictions are integrated and how well they work and how you assess it. So only by doing that can we bridge this gap. So the technology's sound, the number crunching's sound, the science is sound. I mean, and the science doesn't have to be, uh, you know, the science, even to the degree it uses really sophisticated math, there's still sort of a shot in the dark of how good is this? How well is it going to work? Even with the inventors and the researchers and developers, the way you know how good a model is actually just sort of a really, really simple-minded, no-brainer way of assessing it. You try out the model on a bunch of examples that have never before been seen, that were held aside, they weren't used in the development or training of the model, and therefore representative of how good the model is in general. It's that simple. We don't need sophisticated math to or science or to make this stuff work. We just have some good ideas, and then we can check for sure how good it turned out to be. So we have that. The science doesn't have to be that crazy, but there is a bunch of details in the sort of prepping of the data and using the machine learning software that business stakeholders are ultimately not going to get involved in. I mean, I don't know how to change the spark plug in my car. I don't even know, don't tell anybody. I don't even know where the spark plugs are in my car. But to drive the car, I'm an expert. I know momentum and friction, the rules of the road, and mutual expectations of drivers. And to run a machine learning project, it's an analogous amount of expertise that we all need to get on the same page, whether you have a technical or non-technical background. If you're involved with or touched by a machine learning project, which is the best way to improve most large-scale operations, then you need to ramp up a bit, and then you can participate from a knowing way. You can make informed decisions, provide your insights, which are critical, and then ultimately make an informed decision about whether and exactly how to deploy a model and change operations with it.
We are here today with best-selling author and machine learning expert Eric Siegel. In his first book, Predictive Analytics, Eric explained how machine learning works. Now he shows us how to capitalize on it. In his new book, The AI Playbook, Mastering the Rare Art of Machine Learning Deployment. You can find him and find out more at bizml.com. That's bizml.com. Now, Eric, in your book, you present a 6-step process for machine learning deployment. We don't have time to cover each step in great detail, but briefly, can you describe the process and how the elements work together to boost our success with machine learning?
Sure. So the 6 steps, culminate with deployment, and that's the last step. And it's also the first step is you need to plan exactly what that deployment will be. Basically, the first 3 steps are the production planning of the process, where you're bringing together the technical and the business side to make a concrete plan that both adheres to business needs and business constraints and technical capabilities. That is, they involve the 3 things I just mentioned: what's predicted, how well, and what's done about it. Not really in that order. So the first 3 steps are: establish the deployment goal, which is defined as that value proposition. What's predicted and how well? Which transaction is fraudulent? Let's audit it. Which customer is going to respond? Let's send them a brochure. That's the deployment goal. The second is the prediction goal, which is the first of those 2, but in great specificity. So you need to really flesh out all the details. Which customers are going to cancel? Okay, which customers who've been tenured or been around for at least 6 months are going to decrease their spend by 80% in the next 4 months, et cetera, et cetera, et cetera. Get really detailed about all the caveats and qualifiers. Those are business details. The data scientists are not in a position to flesh out those semi-technical details by themselves. You got to get really concrete in that. And then the third is how well, what metrics, how well does it predict? How good is it? How much business value does it have potential to deliver? So those are the first 3 of 6 steps. And then the other 3 are just intrinsic to any machine learning project, which is prep the data, train the model over that data, and then deploy it, which means use the model, use the predictions it outputs, the probabilities, to improve operations. Now, you do have to monitor, maintain upkeep, and refresh the model moving forward thereafter. But in terms of the bare bone framework, actually successfully getting us through to deployment, I've formulated the 6 steps in that way.
Now, Eric, when we last spoke, it was 2019. We were certainly aware and talking about artificial intelligence, but in the time since, artificial intelligence has surfaced, certainly in the last 12 months, to be top of mind. It's in every business conversation. And one barrier to success that you say is has been this overzealous hype surrounding artificial intelligence. It can impede the success of machine learning projects by misleading and distracting business leaders. What do you mean by that? How so?
Well, there's kind of two layers of fog that we have to penetrate before we can reach value. The first is sort of general AI hype, and I believe, there's a lot of misinformation in the general narrative about what generative AI is capable of. I think it's amazing, and I think that it has a lot of potential value, but maybe only 10% or less than what a lot of the hype says. I think that in general, the narrative we hear today says that since this stuff is so seemingly human-like, it's actually a step towards general human-level capabilities. They call that artificial general intelligence, a computer that can basically do anything a person can do. And let's call that what it is, artificial humans. I don't think that we're even at any meaningful step towards that. If we had 5% of that, it would be amazing. It would be really valuable. And that's an overstatement. I don't think we're headed in that direction. I think it's really, really important to see how awesome and amazing these language models are, and as seemingly human-like as they are. And at the same time, realize, boy, they're severely limited when you really compare them to what humans can do in general. That's that's a tricky narrative to tackle. The other layer of fog, though, is even if you dispense with all that sort of anthropomorphizing of machines and that level of AI hype, and you focus really on a concrete value. And what I've been focusing on with you today is mostly these predictive use cases, and that's where you stand to benefit and by improving any existing large-scale operation, or most any. Um, right? That's the established track record of machine learning over decades now. And that's where the majority of still untapped opportunities are, where most of the money is and where most of the value has been proven. So don't forget about predictive. There may be places where you use generative for first drafts or writing, very valuable. But anyway, this second layer of fog is even after you start focusing on a concrete thing. Hey, I'm going to predict which customers are going to cancel, and use that to target a retention offer, like a very concrete, specific, value-driven definition of a use case. Great. You've literally taken only the first of 6 steps. And in that context, still, the vast majority of these projects are failing to reach deployment because it's only the first step. You need to get through all 6 steps. You need to go through the whole practice end to end with deep collaboration that involves business stakeholders in addition to data scientists. And that's the sort of level of detail that has eluded general practice, which is why there's a pretty bad overall success. Plenty of great successes that I cover in the book as well, but the rest of the world stands to catch up, and very, relatively easily really can.
Well, let's talk about some of those successes and some of the power of the predictive aspects that you're talking about in your book. You have a number of case studies that describe how organizations are actively using machine learning to improve their operations and to create competitive advantage across a number of industries. Can you give us an example of one organization that has been successful using your approach? What did they do and what were the results?
Yeah, UPS improves the delivery of 16 million packages a day by predicting tomorrow's deliveries. But I'll let me just outline that story. But first, I'll tell you the book also covers great use in fraud detection by FICO and a couple prominent .coms. And I should also mention that my first book really made an exercise of all the cross-industry deployments. The title of the book, Predictive Analytics, the power to predict who will click, buy, lie, or die, which is both an informal definition of predictive use cases of machine learning and sort of alludes to that cross-industry use. The center color tables of that first book have 147 mini case studies. In any case, and it mentions part of the UPS one just in a sentence or two there. But in the new book, I really delve into UPS and use it as a leading example, and also cover in the conclusion of the book, or the culminating chapter, the deployment chapter. UPS has uncertainty, right? It deals with a lack of information when it has to decide at each shipping center, how do I allocate all these packages to these trucks so that all of tomorrow's delivery routes are as efficient as possible, as tightly packed with deliveries as possible, have as few unnecessary miles driven, unnecessary hours of driving by drivers and uh, gas consumed. So how do they do that? Well, at the beginning of the evening, when they have to start planning and then actually packing the trucks for on-time departures in the morning, um, they know about a bunch of packages that have already reached the shipping center, but there's a whole bunch of other ones that they're unsure of or may not have any information or awareness of because it's a complex system and there's a lot of reasons the information is kind of slow to catch up at that point in time when they really got to get started. So they predict where there will need to be deliveries at what time tomorrow and use those predictions to augment the known packages. So now they have a more complete picture of the likely full set of deliveries tomorrow. Now they can use their optimization system that much more effectively to make all these allocation decisions of which package goes to which truck. When they did that and combined it with a system that actually prescribes the driving, which at the time was new. And it's one thing to say, hey, this truck's been packed with a bunch of packages that can potentially be delivered very efficiently with an efficient route. That doesn't mean it will be unless the driver is prescribed the most efficient route, right? So when you combine those two things together, because of that, UPS saves 185 million miles of driving a year, 8 million gallons of fuel, and 185,000 metric tons of emissions.
We are here today with Eric Siegel. We're talking about his book, The AI Playbook, Mastering the Rare Art of Machine Learning Deployment. And listen, if you're enjoying this interview, you've got to go back in the archives and check out when Eric visited us back in May of 2019. He talked about his book, Predictive Analytics, explained how machine learning works, and now he's here to talk about how to capitalize on it. You can find out more and find Eric at bizml.com. Now, Eric, we have reached the action item round of the program. I'm wondering if you could please provide us with 3 quick action items that our listeners can do to begin to take advantage of the ideas and advice in your book.
Yeah, and I'm ready for this question. Number one, ramp up on the semi-technical understanding of machine learning. Look, if you thought high school algebra was boring or arcane, you're right, because typically that's how it's taught. But look, the kind of understanding you need to get, not the core rocket science, but how to make use of and make value from the rocket science and the semi-technical understanding, it couldn't be more interesting, fascinating, pertinent, relevant, and exciting, right? This is the last remaining differentiation point for improving large-scale operations across enterprises. This is what it takes. Predictions, the holy grail for driving decisions, and to get it to work into operation, not just do the number crunching, but get it deployed, takes a you know, it takes a community of people that are all ramped up, whatever your background is. So what's predicted, how well, and what's done about it into that level of detail. That's the purpose of the book, is to ramp up readers. It also ramps up data scientists. There are aspects they haven't thought about yet, and they need to understand what their business stakeholders need to understand. Number 2 of 3 is get started, right? So that is, what's the best opportunity, the best untapped opportunity for machine learning at your organization? Well, what's the large scale operation? I mean, in general, business is a numbers game, and we're tipping the odds a little bit in our favor, which amounts to dramatic improvements on the bottom line by informing all these decisions with predictions, with probabilities. So what's the large scale operation in marketing, fraud detection processes, financial credit risk management, whatever you're doing out there on a large scale, that's where you've already been accumulating the data, and that's where you have the opportunity to improve and see meaningful improvements. So find that opportunity. And then if you want to start putting it into action, you need to make sure there's somebody who's going to lead the project end to end and facilitate this collaboration. My first vote would be that you lead. If you want something done well, do it yourself. If you don't want to be a leader, that's okay, no pressure. But the fact is, it's generally omitted. A full holistic process that leads these projects end to end and really facilitates that collaboration along every step along the way. Um, it's few and far between. It certainly happens, but more often it doesn't. So it could be hard to find somebody who's got their head around it, who's read this book or kind of ramped up or learned from enough years of hard experience. Um, if you're thinking about it and you're aware of the need, you're in potentially the best position to take it on, or at least, make sure somebody does.
Well, Eric, it's been great speaking with you today. We're almost out of time, but before I let you go, one last question. What should executives and business owners be thinking about now and strategizing for today in order to be prepared for the world in 5 years' time?
Well, I think the most important thing is, I mean, the antidote to hype and the sort of layers of fog I talked about is to focus on concrete value, concrete use cases that are plausible, feasible, and that are going to actually be put in into realistic motion, and put a project leadership practice in place that's going to actually get you there. That's sort of the opposite of hype, which is sort of pipe dreams and super sort of grandiose excitement about what it means for a machine to be intelligent, and sort of a narrative that says, hey, it's going to be autonomous, right? What's going to be autonomous? Are you going to be able to onboard a computer like a new employee and let them rip on their own? Not really. It's helping with specific tasks and it's extremely valuable to that end. And in that way, we're tapping what computers are better at than humans, in sort of large scale number crunching and tireless work and clarity and lack of mistakes and all these kinds of things. So be prepared for mass disillusionment, if not an AI winter around the hype where these sort of mismanaged over expectations fail to be met inevitably. And that's going to be painful. But to the degree you've been focused on concrete value, you've been delivering value, it's real, it's not just a story. Um, and yeah, so I think that's the main thing to be prepared for, is to keep the value increasing and try to keep the hype in its place.
That is Eric Siegel. Get his book, The AI Playbook, Mastering the Rare Art of Machine Learning Deployment. Well, Eric, thank you so much for being our guest today on the Digital Transformation Podcast.
My pleasure, Kevin. Thanks so much for having me.